hi, I'm Matt. I'm from the Parliamentary Digital Service. You might have heard of GDS. We're much, much better. We're about Parliament rather than government. Talk to me about that later. So I'm here to talk to you about GROM. GROM is a graph object mapper. So I'm going to go a little bit into what that is in a minute. So you might recognize here, this is where I work. So GDS, work in an office building. I work in a palace. Definitely better. So what is a graph database? So I've got a couple of trivial examples on the screen here. So in the top right is a table that I stole from Google in my rush to make these slides. Looks like a person table. You can see there's kind of like regimented information there, first name, last name, and address. Ideally, they should have normalized this into a different table, but we won't go there. City and age, so there's sort of like people-y sort of information. And then in the bottom right, this is a snippet of Parliament's graph database, so that also represents information about a person. It's kind of a bit different. So why is it different? So instead of having a table, like a user table that you query against, so you have a table and you would say, hello database, I would like all the users, I want their name to be Theresa May, and you get back the information for that person, you ask for additional stuff, and you kind of get back a blob. Whereas with a graph, it's a collection of nodes, so a node might be Theresa May, and there might be another node, which is Maidenhead, which is her constituency. And then the way you query a graph is instead of asking for information, you kind of massage it. So you say, hello graph, I would like sort of people things. It'd be good if their name was Theresa May. I want all the other stuff that's Theresa May-y. And then you get back kind of on the surface, like if you shake like a cake mix and all the big bits come to the top, you kind of shake the graph and the big bits come to the top and you cream it off and that's your result. And what you get is a graph of stuff rather than a thing. Now, why is that different? Well, at Parliament, we've got 850 years worth of information. And the further back in time you go, it gets really sketchy. So, for example, Winston Churchill, quite a major name in the UK, we don't actually have complete information for him currently in our system because record keeping was rubbish. So graphs allow a little bit more flexibility. So things can or may not have certain attributes. So it leads to an interesting challenge. So all of our sites, our new site anyway, is built in Rails. An active record doesn't really work for us. So we invented GROM instead. So what does GROM do? So GROM dynamically creates objects using metaprogramming at runtime based on graph stuff. So these objects may or may not have attributes attached to them. It allows you to filter results. So if you asked for Theresa May things, one of the things you get back is Maidenhead. But if you're making a Theresa May web page, you would only want the Theresa May thing first and then all the link stuff hanging off of that. So it allows you to kind of bring a little bit more order to that graph of random results. And it effectively allows us to replace active record in Rails. Now, it's not the best finished product thing in the world. We're still working on it. Our site's in beta. You can go to beta.parliament.uk to check it out. And it's a moving process. So following on from one of the talks yesterday, probably going to look at using Helix to improve it. It's quite slow at times. But it's interesting the challenges that we have with dealing with graphs in production, because normally they're very academic or they're used in certain small things. And GROM allows us to still use all the Railsy stuff that we love, but not be shackled by active records' desire to have everything in a relational database. That's it really for my talk. I don't know if that was particularly helpful. Bear in mind it was 20 minutes. Yeah.
Thank you.